All right, hello, welcome guys. We are going to be sticking with some non-real and complex zeros of polynomials as we work through this video, and we are going to be talking about factoring polynomials when you are now given a non-real zero. So earlier in the year, we factored some higher degree polynomials like x cubed, x to the fourth, when we're given a real zero. And we would start off by dividing the function by that factor, divide until we can get it down to a quadratic, use the quadratic formula, or maybe just factor the quadratic like we learned back in Algebra 1. In this case now, for this example, we are going to be given a non-real zero though. And how is that going to change our approach of the problem? So we're going to run through this example problem. We are going to find all zeros of f of x, given that x equals 5 minus 2i is a zero of the function. All right, and we have the function given below. F of x is equal to x cubed minus 14x squared plus 69x minus 116. So again, if I had given you a zero, you would say, all right, well, I know x minus that zero is a factor, so let me divide by that factor. So in this case, yeah, sure, let's do some synthetic division. By 5 minus 2i, though, do we really want to do that? There's just a lot of room for error when you do it in this way. Could you? Yeah, you definitely could. If you only can do synthetic division, then you're going to have to do it this way. But luckily, everyone at this point should know polynomial long division. So that's the method that we are going to use for this problem. However, again, we don't really want to divide by i's. It's just complicated. All right, it's just making the problem harder on ourselves. So let's figure out a way we could divide without any i's involved. Well, to start off, I know if x equals 5 minus 2i is a 0, then x equals 5 plus 2i also has to be a 0. Also is a 0. Right? We know that complex zeros or non-real zeros come in pairs with its complex conjugate. So if 5 minus 2i is a 0, so is 5 plus 2i. So then that tells us for f of x has two factors that we know of now. It has factors of x minus 5 minus 2i and x minus 5 plus 2i. Sorry if you heard that bell. That's just a bell meaning classes are supposed to be switching, but virtual school right now, so none of that. All right, so we know f of x has factors of x minus 5 minus 2i and x minus 5 plus 2i. Well, the cool thing and what's going to help us out is if we're actually to multiply these two together, we will get a new factor of f of x. All right, and the reason that that's so important is if we multiply these two together, we can get rid of those i's. We can get a quadratic function that only has real coefficients. All right, so that's what our goal is going to be here is, well, let's find another factor of it. Must be, again, the product of these two, x minus 5 minus 2i times x minus 5 plus 2i. So multiplying these together, yeah, we could show out every single one of these. Remember, like negative 2ix and positive 2ix are going to cancel out. So this is really just the same thing as doing x minus 5 squared. So x minus 5 times x minus 5. And then multiplying negative 2i times positive 2, which is a negative 4i squared, and adding that on after. Which, of course, that is equal to x squared minus 5x gives us minus 10x plus 25 plus 4, which is x squared minus 10x plus 29. And we are saying that is a factor of f of x above. All right, that's a factor of f of x above. Let's go to the next slide. It should just have f of x and then that factor. All right, great. So if we have a factor of f of x, let's now divide by that factor. We know when we divide, we should get a remainder of 0 because that's what it means to be a factor. So let's just run through this. Minus 116. And we're going to divide that by x squared minus 10x plus 29. All right, so I start off x cubed divided by x squared is just x. Multiply x by everything to the left. X cubed minus 10x squared plus 29x. Throw some parentheses around that so we're not messing up on our negatives. Negative 14 minus a negative 10, that's plus 10, is negative 4x squared. 69 minus 29 is 40x. And then we'll bring down that minus 116. Divide negative 4x squared divided by x squared is just a negative 4. And now bring down this, multiplying negative 4 by everything over to the left. We get negative 4x squared plus 40x. Negative 4 times 29 just so happens to be negative 116. If we subtract those, everything cancels, which guess what? It needs to. Right, we need to get a remainder of 0 because I'm saying x squared minus 10x plus 29 is a factor. So if we divide by it, again, our remainder should be 0. All right, so now I know f of x is equal to, well, writing it out, x squared minus 10x plus 29 times x minus 4. I'm sorry, I ran out of room there. All right, but we're just taking this and multiplying it by this has to give us our original, right, x cubed minus 14x squared plus 69x minus 116. All right, so let's now talk about, well, what are my zeros of the function? I know to start, if I go back, I was given x equals 5 minus 2i. Okay, and of course, these are all x equals. X equals 5 plus 2i is also a 0 of the function. And then x equals 4 is a 0 of the function. All right, if you were to plug in 4, you should get out 0. So now the question is, how do we really want to write f of x? So there's two different ways of writing f of x. One of them is just as a product of the linear factors. And what does that mean? It's just like what we saw earlier with factored form, where we would write, oh, f of x is x minus 1 times x minus 4 times x plus 2. Okay, it's the same thing here. We would write f of x as x minus each of its zeros. So x minus 5 minus 2i, x minus 5 plus 2i, and x minus 4. That would be its product of linear factors. And the second one, this product of linear and irreducible quadratic factors, the reason this irreducible quadratic factors just has to do with these non-real zeros that we have. It doesn't look pretty when we have these i's. All right, it makes the function a little bit ugly. We don't necessarily want those. So instead of writing these two out separately, each as linear factors, we'll write it as an irreducible quadratic. And that irreducible is just saying, yeah, when you try to do the quadratic formula on it, we're getting some non-real zeros. All right, and of course, we already did that multiplication earlier as x squared minus 10x plus 29 times x minus 4. All right, so here we can see we only have one real zero and two non-real zeros for this function. Hope this helps you guys out. Best of luck on your homework.